Okay, so let's go ahead and take a look at problems 12 through 19, the portion of the review that talks about factoring. So sometimes factoring is the question, and sometimes factoring is just a tool to finish answering a question. So I want to be very, very clear that there's something going on here that the math teachers are a little concerned that people will overdo. So without any further ado, here we go. So one of the things that we always want to remember as we look through these problems is we want to look for greatest common factors. And so as we look through these problems, I'm going to highlight a couple of them. When I look at this number right here, this has a coefficient of a 1 and a 2 and a 48. There's absolutely nothing shared in common with those values. However, if you look at a problem like number 15, what you're going to notice is all three of those coefficients are divisible by specifically the number 5. That's a very, very helpful thing to notice. In number 14, all of these values are divisible by 3. And in this last one, everything here is actually divisible by both 3 and by x. So how about this guy? Well, I've got a 6 and an 11. 11 is a prime number. That's a big trigger right there. There's nothing that divides except for 1 and 11, and those don't fit into 6 or 7. So I need to think of the GCF specifically on these problems. So please, please, please remember to think of GCF. Part of that is it's going to make your problems much smaller as you work through there and therefore make them easier to deal with. So if you look at number 12, the first thing that I notice is that both of these numbers have a 3 and they have an x. Well, based on the distributive property, what has to go right here if the product of 3x and something is 3x squared has to be an x. Now, and 3x times something has to be minus 5. And so we've actually already finished that problem. Now, I do know some of the other teachers are doing this, and they're making this as a box, and they're thinking about what it is that they have in common and developing that through the box method. And that's perfectly fine. That's great too. But notice that once I did that GCF, I know that I'm done because I have two very simple factors. And if I tried to graph this one, it looks like y equals x minus 5, which is a simple little line. Then that's what we're trying to do, is get each of these pieces to look like little pieces of lines. Now, the second question, number 13, is a little harder. And I know not all of the teachers are using the little diamond thing. My classes are. And so what I always put on the top piece is the product of A and C. So 1 times negative 48 is negative 48. And I put the negative 2 down here. And so I need to come up with two numbers whose product is 48, like 1 and 48, 2 and 24, 3 and I think it's 16, 4 and 12, or 6 and 8. But because their product is negative, one of those numbers has to be negative. And in fact, the larger of the two numbers has to be negative, because if you add numbers and you get a negative, the bigger number has to be negative. And so if this problem is factorable, it has to be one of these. And I think we could very quickly see that 6 and negative 8 are our values. And so because A is 1, and this is very, very important, because A is specifically 1 in this case, we actually don't need to make a full box. We can really just take the numbers that are sitting over here in my diamond and have my problem done. And keep in mind, this problem says factor, and that's all I wanted, is I wanted to break it down. Okay, number 14. Tiny bit harder. Notice I put it in yellow because there's that GCF. Well, I noticed that if I could steal the 3 out of this front piece, the second piece, and the last piece, again, if you multiplied it out, 3 times x squared is still 3x squared. It all fits. So now I'm going to go ahead and cover up this 3, and the product of A and C is 24. Now, I think this is a fairly easy problem. If they multiply to a positive, but they add to a negative, both of these numbers would have to be negative. And in fact, 6 times 4 would do it. So we've got a 6, we got a 4, and again, because the leading coefficient now kind of looks like it's a 1, I could do x minus 6 and x minus 4, and I'm done. Now again, I don't really need to do the full box method for this problem because I have a problem that after I pulled out the GCF, I got a coefficient of 1. Now, that falls apart on number 15. This is the hardest. These two problems right here are the tougher questions as we go through them. So the first thing that we mentioned already is that they both had a 5 in common. All three of them, in fact, do. So 5 goes into 15 3 times, 5 goes into 70 14 times, and 5 goes into 120 24 times. Well, now, even if I cover this 5 up, my leading coefficient is not 1, so that means I have some work to do. So I need to make my diamond, and I have to say, when I first did this problem, I kind of messed it up, and I had to realize, oh, I didn't go very far, but I forgot to multiply the 3 by the 24, because I got a little lazy with these other problems. And honestly, I had a trouble finding out what number actually makes this work, because again, I got one positive and one negative, and I honestly didn't know what number works, but I know 3 goes into all sorts of values. In fact, if you need a calculator, we can do that. We can say, well, shoot, 72 divided by 3. There was 24. We could do 72 divided by 4. Oops, 72 divided by 4. We'd have 4 and oh, hey, there's my answer right there. Because I was looking for something that makes that 72 happen. So 72 divided by 4 would be our value. Now, here comes the not so fun portion of the story. Is, again, we're going to ignore this 5 for a moment. But we're going to put our 3x squared here and our minus 24 there. And then what we're going to be doing is we're going to be splitting this negative 14 piece that we have right there between the 4x and the minus 18x. So keep in mind, as we do this work, this portion is here, which is really replacing that portion. So keep in mind 14, 14, and we've got 14. And so if we look for common factors, I notice these are both divisible by both 3 and x. So 3x times x times 4, and last, 3x times negative 6 would work, and therefore, remember, I still have my 5 from above, and then my two little linear factors are 3x plus 4 from this part, and x minus 6 from that part. Now, keep in mind, we can check our answers by multiplying it back out. But the cool thing is if you look right here, we did multiply it out. You can see the 3x squared. You can see the 14 and the 24. So we have the process where we can look at it going forward to factor it, or we could look at it going backwards to multiply it out, like what we did in the problem 6 through about 11 of the review. Okay, last problem. Now, notice I put a star there because it was a hard problem, but it didn't have a GCF. So we can just jump right to our story and think through numbers that multiply to 42 that add to negative 11. So 42 could be like a 7 and a 6, but that doesn't work. But, that's a hint. If 7 goes in there 6 times, then if 6 goes in, then so do 3 and so do 2. And so as it turns out, that's the magic story for this particular problem, is that it is actually divisible. I'm looking back at what I wrote down in my notes, is that it turns out it is divisible by 3 times 14, because 3 times 14 is 42. And so again, making our box, remember we always put the leading term here. We put the trailing term here, and then these last two pieces, the 3x and the negative 14x, again, trying to just make sure I'm being consistent here. These pieces are what make up that 11. And so all we have left to do is look for commonalities. And I notice these are both divisible by both 2 and x. So 2x times 3x. 3x times 1 would be 3x. And 2x times -7 would be -14. And we are done. Cool. Now, again, if you are of the mind to do so, it's not a bad idea to go into Desmos. And if you typed in this question, and then as the next line down, you typed this in, those two graphs should be exactly the same. So I think it's worthwhile to do one of those real quick. So I still have this graph from a previous question, but let's see what we got. I wanted to see what the graph of 6x squared is minus 11x minus 7. Now, the fact that this is really stretched down doesn't matter too much because I just want to make sure that I did this problem right. So when I did it, I got 2x plus 1, and I got the second factor was 3x minus 7. And if I have done it right, they should be exactly on top of each other. And that's what you'd see. Notice that if I turn the blue graph off, turn the black graph on, they're exactly the same. And that would be a nice confirmation that I did okay. All right, let's finish this thing up because now we have transitioned. And this is our last part, is this does not ask me to factor, it asks me to solve. When I factor, because I do need to factor, that is just part of the process. So I'm going to look for two numbers that multiply to 56 and add to 15. And of course, my teacher always told me that 7 times 8 is 56. That's one of those little cadences that I don't know why I remember from elementary. But 8 minus x, x minus 7 and x minus 8. Remember, a was 1, so I didn't have to do anything fancy. And the zero product property says the only way that this product can be 0 is if one of these pieces is 0. So if I wanted this piece to be 0, I would need x to be 7. If I wanted this piece to be 0, I would need x to be 8. And keep in mind, if I plugged in either one of those, I would get that. Because 7 minus 7 is 0. 7 minus 8 is -1, and 0 times -1 would in fact be 0. You could also check on the test by plugging the 8 or the 7 back into the original problem, and it also works. Now, number 18, I'll go ahead and use my yellow color code because it has a GCF. Everybody here is divisible by 4, but the cool thing here is I'm going to divide each piece through by the number 4, and I don't need to keep the 4 because it's a full-blown equation. So when I divided both sides by 4, it just went away. And the problem, though, is we really need things to be equal to 0. So I'm going to take 40 away from both sides because if I subtract that 40, I'm going to get that. And just like this problem, I have a nice, easy problem where a is 1. And I know that 8 times 5 is 40. But of course, if their product is negative, one of those numbers must be negative, and it has to be the smaller. And so I've got x plus 8 and x minus 5. And we are ready to go because the number that would make that first one 0 would be -8. And the value that would make that one 0 would be +5. Now, just for fun, we could come back in here to this problem and just check it out. If I plugged in, say, 5, what is 4 times 5 squared? Plus 12 times 5, because I said 5 should be an answer. Well, if I hit enter, this is supposed to be 160. And what do you know? That does confirm that I did that problem well. Or I could take 4 times -8 squared plus 12 times -8, and if that should also give me the number 160, and it does. Okay, so our last question for our review is right here, number 19. So again, we really don't want things to be set equal to anything other than 0. And this problem was set equal to something other than 0. And again, oh my goodness, look at that. Everything here is divisible by 2. So if I divide each piece by 2, 0 divided by 2 is 0. The problem just gets smaller and smaller and smaller. So I could do my A times C. I could put my B value here. And Mr. Wheeler got tricky on this one because everybody forgets that one of the things that always divides into any number is the number 1. When you see 15, everybody thinks of 3 times 5, but 15 times -1 would multiply and add appropriately. And so let's go ahead and I'm going to make my box over here on the far right side since I have some room here. We put our first term here, our last term there, and we're going to split up our 14. Again, just being consistent with my colors, that these things are going to go here, and I'm going to put my 15x here and my -1x there. And I'm going to look, hey, these only have an x in common. So x times 3x, x times -1 would be -x, 5. And so my factors would be 3x minus 1 times x plus 5 is 0, which leaves one of my answers right there to be -5 fairly clearly. But I also need that to be 0. So I'm going to add 1 to both sides. And I'm going to divide both sides by 3. And I got 1/3. And that looks a little tricky. So I will do one last little thing, and that is to check my 1/3 and see how I did. And I wanted to do this because I know not everybody knows they can do this. So according to this problem, I'm going to take 6 times 1 fraction key 3 squared. That's 6 times 1/3 squared, plus 28 times 1 fraction key 3. That's 28 times 1/3. And minus 3. Now, if I have done this right, my answer should be 7. And in fact, it is. And if I wanted to, I could do that again and try the number -5 to clarify that answer as well. But I don't think we need to do both. I think it's good enough to do one. So hopefully that was helpful. And I will see you guys back in class. Good luck.